What if I told you there's a Chevrolet engine so powerful, so radical, that GM deliberately lied about its horsepower just to keep insurance companies from catching on? An engine that required fuel you couldn't buy at normal gas stations. An engine that came with a warning label telling owners not to drive it on the street. This is the story of the L88 427, the most misunderstood, underrated, and devastatingly powerful big block ever smuggled into production cars. Picture this. It's 1967 at a drag strip somewhere in America. A new Corvette rolls up to the line. The guy in the other lane sees the crossed flags on the hood and relaxes a little. Just another Corvette, right? The light goes green. 11 seconds later, that Corvette is crossing the finish line at over 120 miles per hour, leaving everyone wondering what the hell just happened. The owner claims it's stock. The time slip says that's impossible. Both are telling the truth. The Chevrolet L88 427 cubic inch V8 represents one of the most audacious acts of automotive deception in history. Officially rated at just 430 horsepower, this engine was actually producing 560 or more at the flywheel. Some say it was the greatest lie ever told in Detroit. Others call it genius marketing. The truth? It was both. This is the story of how Chevrolet built a race engine, called it a street engine, and created a legend that still makes grown men weak in the knees over 50 years later. To understand why the L88 exists, we need to travel back to the mid-1960s. The muscle car wars were reaching nuclear levels of insanity. Ford had the 427 Cobra, Chrysler was dropping 426 Hemis into everything that moved. The streets of America had become proving grounds, and every stoplight was a potential battlefield. Chevrolet's response had been respectable, but not revolutionary. The L71 427, with its triple carburetors, was potent at 435 horsepower, but Zora Arkus Duntov, the father of the Corvette, knew they needed something more extreme, something that would dominate not just on the street, but on the track where reputations were really made. The problem was General Motors' corporate ban on factory racing involvement. Officially, GM wasn't in the racing business. Unofficially, they needed to win races to sell cars. The solution? Build a production engine that just happened to be perfect for racing. Make it technically available to the public, but make it so hardcore that only serious racers would actually want it. And most importantly, rate it conservatively enough that the insurance companies and corporate executives wouldn't realize what was really going on. Enter the L88. Development began in 1966 under a veil of secrecy that would make the CIA jealous. The foundation was the existing Mark IV 427 big block, but that's where the similarities to normal engines ended. The first revolutionary change was the heads. While standard 427s used iron heads weighing about 75 pounds each, the L88 got aluminum heads that weighed just 45 pounds each. That's 60 pounds of weight savings right off the top of the engine, literally. But these weren't just lighter versions of the iron heads. The ports were massively enlarged, the valves were huge at 2.19 inches intake and 1.84 inches exhaust, and the combustion chambers were designed for one thing: maximum airflow at high RPM. The compression ratio was set at a brutal 12.5.1. Let that sink in for a moment. Most street engines of the era ran 10.1 or maybe 11.1 if they were aggressive. Modern engines, with all their computer controls and knock sensors, rarely exceed 11.1. The L88 was running 12.5.1 in 1967. This wasn't just pushing the envelope, this was setting it on fire. At this compression ratio, detonation wasn't a possibility, it was a certainty with pump gas, which is why the L88 required 103 octane fuel minimum, not recommended. Required. The camshaft was essentially a full race piece with a low-P idle that sounded like the engine was about to stall at any moment. The solid lifters required regular adjustment and made a characteristic ticking sound that let everyone know this wasn't your average grocery getter. Duration was 337 degrees on the intake and 340 on the exhaust with .520 inches of lift. For comparison, a typical street cam of the era might have 280 degrees duration and 450 lift. The L88 cam kept the valves open so long that at idle there was significant overlap, creating that distinctive lumpy sound that screamed performance. The intake manifold was an aluminum high-rise unit designed to feed those massive ports. On top sat a single Holley 850 CFM 4-barrel carburetor. Now 850 CFM might not sound extreme today, but in 1967 most big blocks were running 600 or 650 CFM carbs. The L88's carburetor was sized for racing, period. It could flow enough fuel and air to support well over 600 horsepower. The fact that it was rated at only 430 should have been everyone's first clue that something didn't add up. The bottom end was built like a bank vault. The block itself was a special high-nickel casting with 4-bolt main bearing caps. The forged steel crankshaft was cross-drilled for improved oiling and balance to handle sustained high RPM operation. The connecting rods were forged steel, much stronger than the cast units in regular 427s. The pistons were forged aluminum pop-ups that created that astronomical compression ratio. Every component was selected for one purpose: to survive at maximum power for extended periods. Independent dyno tests told a very different story. With just basic tuning and the factory exhaust manifold still in place, the L88 was putting down 480 to 500 horsepower at the flywheel. With headers and optimal timing, 560 to 580 was common. Some builders were seeing 600 or more with careful tuning. The engine was making peak power around 6,500 RPM, not the claimed 5,200. The torque was equally understated, with real-world numbers approaching 500 lb-ft. To put this in perspective, the L88 was producing roughly the same power as NASCAR engines of the period. This was a full race engine that you could order from your local Chevrolet dealer. Well, theoretically anyway. Chevrolet made ordering an L88 about as pleasant as scheduling a root canal. First, it was expensive. The option cost $947.90 in 1967, which is about $8,500 in today's money. That was on top of the already pricey Corvette. But cost was just the beginning of the deterrence. If you ordered an L88, you couldn't get a radio. Not wouldn't, couldn't. The option sheet literally blocked you from ordering one. No heater either. The L88 came with a special cowl induction hood that sealed to the air cleaner at wide open throttle, and there was no room for heater boxes. Air conditioning? Forget it. Power steering? Nope. Power brakes? Not a chance. Every power accessory was deleted to reduce parasitic losses, and because the engine bay was so cramped with the massive aluminum heads and intake that there wasn't room for much else. The car came with a sticker on the console that read, "Warning, this vehicle is equipped with an L88 engine and is intended for closed-course competition use only. Proper fuel and operating procedures must be observed." Another sticker specified that 103-octane minimum fuel was required. In 1967, finding 103-octane fuel meant going to an airport or a racetrack. Your local Sunoco wasn't going to cut it. The first year, 1967, Chevrolet built just 20 L88 Corvettes. 20. That's not a typo. The following year, 1968, production exploded to 80 units. In 1969, the final year, 116 were built. That's 216 total L88 Corvettes produced over 3 years. To put that in perspective, Chevrolet built over 20,000 Corvettes in 1969 alone. The L88 was less than 1% of production. But those 216 cars left a mark on motorsports that's hard to overstate. At the 1967 12 Hours of Sebring, L88 Corvettes finished first and second in the GT class. At the 24 Hours of Le Mans, an L88 Corvette was clocked at 171 miles per hour on the Mulsanne Straight, faster than many prototype racers. In SCCA competition, L88 Corvettes were virtually unbeatable in a production class. On drag strips across America, they were running low 11-second quarter miles right off the showroom floor and high 10s with slicks and headers. The most famous L88 racer was probably the Owens Corning Corvette, driven by Tony DeLorenzo. This car dominated SCCA A production racing in 1968 and 1969, winning multiple national championships. What made it even more impressive was that it was running against purpose-built race cars while still maintaining its production status. The L88 proved that with enough engineering prowess, you could build a street-legal car that could humiliate purpose-built race cars. The engineering deep dive into what made the L88 so special reveals just how far ahead of its time this engine was. Those aluminum heads weren't just about weight savings. The aluminum conducted heat away from the combustion chambers much more efficiently than iron, allowing the engine to run that insane compression ratio without detonating itself to pieces. Well, as long as you fed it the right fuel. The rectangular ports were massive, flowing over 300 CFM on the intake side. For comparison, a good street head of the era might flow 200 CFM. The valve train was designed to control those massive valves at speeds that would turn regular engines into boat anchors. The solid lifters were necessary because hydraulic lifters would float at the RPMs the L88 was designed to run. The valve springs were so stiff that they required special tools to compress during assembly. Spring pressure was 350 pounds on the seat and over 500 pounds at full lift. The rocker arms were specially heat-treated to handle the stress. Every component was overbuilt to race specifications. The cooling system was equally extreme. The L88 came with a special heavy-duty radiator with a shroud and a clutch fan that could move massive amounts of air. The water pump was a high-flow unit that could circulate 50% more coolant than standard pumps. Even the thermostat was special, opening at 180 degrees instead of the usual 195 to keep temperatures under control during extended high-speed operation. The fuel system had to feed this monster's appetite. That 850 CFM Holly was jetted rich from the factory, and owners were instructed to run even richer jetting for race use. Fuel consumption at full throttle was measured in gallons per minute, not miles per gallon. The fuel pump was a mechanical unit capable of supporting over 600 horsepower. The fuel lines were larger than standard, and the fuel filter was a high-flow racing unit. The exhaust system was a study in contradictions. From the factory, the L88 came with cast iron exhaust manifolds that were surprisingly efficient for their design, but still restrictive compared to headers. The factory mufflers were chambered units that provided minimal sound deadening. But here's the clever part. The exhaust system was designed to be easily replaced. The manifold bolts were accessible, the pipe routing was straightforward, and everyone knew the first thing any L88 owner would do was install headers and straight pipes. The transmission options were limited to the serious stuff. You could get a 4-speed manual, either the M21 close ratio or the M22 rock crusher heavy-duty unit. The M22 got its nickname from the noise it made, a distinctive whine caused by the straight-cut gears that were stronger than helical gears. The automatic option was the Turbo Hydromatic 400, a 3-speed unit that was virtually indestructible. Both transmissions were built to handle far more torque than even the L88 could produce. The rear axle was equally overbuilt. Standard was a positraction differential with 3.70.1 gears, though 4.11.1 and 4.56.1 ratios were available. The differential case was the heavy-duty unit with larger bearings and stronger axle shafts. The whole assembly was designed to handle the violent launches that drag racing demanded without grenading itself. What really separated the L88 from other performance engines of the era was its racing pedigree. This wasn't an engine that was adapted for racing. It was designed from the outset to race. Every component choice, every engineering decision was made with competition in mind. The fact that it was technically street legal was almost an afterthought. Chevrolet needed to build 50 units to homologate it for production-class racing. They built 216 over 3 years, just enough to keep it legal and not enough to attract unwanted attention. The stories of L88 owners discovering what they really had are legendary. One owner reportedly took delivery of his new L88 Corvette and immediately drove it to the drag strip. On his first pass, running street tires and pump gas he'd added to dilute the race fuel from the dealer, the car ran a 12.8-second quarter mile. He thought something was wrong. After switching to slicks and proper fuel, he ran an 11.2. He still thought something was wrong because the car was supposed to have 430 horsepower, not run times that suggested 550 or more. Another owner, frustrated with the lumpy idle and difficulty starting when cold, took his L88 to the dealer for service. The mechanic, not familiar with the L88, attempted to tune it up by installing a milder cam and smaller carburetor. The owner returned to find his car running smoothly but completely gutted of power. When he discovered what had been done, the ensuing lawsuit became the stuff of Corvette legend. The dealer had to source another complete L88 engine to make it right. The insurance companies eventually caught on. By 1969, insuring an L88 Corvette was virtually impossible for anyone under 30, and even then, the premiums were astronomical. Some owners registered their cars with the base 350 engine code to avoid detection. Others simply trailered them to the track and never bothered with street registration. The L88 had become too hot to handle, which was probably Chevrolet's plan all along. The cultural impact of the L88 extends far beyond its limited production numbers. This engine proved that American manufacturers could build engines that were every bit as sophisticated as anything from Europe. The aluminum heads, high compression, and race-specific components showed that Detroit understood high-performance engineering at the deepest level. The L88 wasn't just brute force, it was intelligent application of racing technology. The L88 also established a template that manufacturers still follow today. Build a limited number of extreme performance models to homologate for racing and establish brand credibility. Price them high enough to limit demand. Make them uncomfortable enough that only serious enthusiasts will tolerate them. The formula worked then, and it works now. Every modern track-special supercar owes something to the L88's playbook. The legacy of the L88 in motorsports is equally impressive. The technology developed for the L88 filtered down into other Chevrolet performance engines for decades. The aluminum head technology pioneered on the L88 eventually became standard on performance big blocks. The high-flow port designs influenced small block development. The valve train components became the basis for countless racing engines. Even today, the L88 designation carries weight in racing circles. Reproduction L88 engines are built by specialty shops for vintage racing, and they still competitive 50 years later. The collectibility of original L88 Corvettes has reached insane levels. These cars routinely sell for 7 figures at auction. The most expensive Corvette ever sold at auction was a 1967 L88, which went for $3.85 million in 2014. That's not a typo. Nearly $4 million for a car that listed for about $5,500 when new. The appreciation rate makes Bitcoin look stable. But it's not just about money. L88 Corvettes are rolling pieces of automotive history, monuments to a time when engineers could build something truly extreme and sell it to the public. The technical innovations of the L88 were revolutionary for their time. The use of aluminum heads on a production engine was almost unheard of in 1967. The 12:5:1 compression ratio pushed the boundaries of what pump gas technology could support, which is why it required race fuel. The valve sizes and port volumes were larger than many dedicated race engines. The single four-barrel carburetor setup was elegantly simple compared to the multiple carburetor setups on other high-performance engines, yet it made more power. Modern engine builders studying the L88 are still impressed by its design. The combustion chamber shape was remarkably efficient for its era. The port angles and volumes were nearly optimal for the RPM range the engine operated in. The valve train geometry was spot on for high RPM stability. This wasn't just parts thrown together, it was a carefully engineered system where every component was optimized for maximum performance. The influence of the L88 on modern performance cars cannot be overstated. Today's factory special editions like the Dodge Demon, Shelby GT500, and Corvette Z06 all follow the L88 formula. Take a production car, add barely streetable race components, price it high, build limited numbers, and let it establish the brand's performance credentials. The L88 proved this formula could work, both commercially and in competition. But perhaps the most remarkable thing about the L88 is what it represented philosophically. This was an engine that didn't compromise. In an era when manufacturers were starting to think about emissions and safety, Chevrolet built an engine that said, "Forget all that, let's go racing." It was a pure expression of performance, undiluted by practical considerations. It required dedication from its owners. You had to find race fuel. You had to adjust the valves regularly. You had to live with no heater, no radio, no creature comforts. But in return, you got a street-legal race car that could humiliate almost anything else on the road or track. The engineering philosophy behind the L88 was beautiful in its clarity. Every decision was made in service of one goal: maximum performance. If a component added weight without adding power, it was deleted. If a material was stronger but more expensive, they used it. If a design was better for racing but worse for the street, they went with the racing design. This single-minded focus created an engine that was greater than the sum of its parts. Today, the L88 story serves as inspiration for engineers and enthusiasts alike. It reminds us that sometimes the best approach is to throw compromise out the window and build something extreme. It proves that with enough engineering talent and corporate willingness to push boundaries, you can create something legendary. The L88 wasn't just an engine, it was a statement, a declaration that American engineering could compete with anyone, anywhere, at any time. The fact that Chevrolet got away with it for 3 years is remarkable. They sold a race engine to the public, lied about its power output, and created a legend in the process. The insurance companies were fooled. The corporate executives were kept in the dark. The racing sanctioning bodies accepted it as a production engine. It was one of the greatest acts of automotive subversion ever pulled off. Looking back over 50 years later, the L88 stands as perhaps the ultimate expression of the muscle car era. It wasn't the most powerful engine ever built. It wasn't the most exotic. It certainly wasn't the most practical. But it was the most honest in its dishonesty. Everyone knew the 430 horsepower rating was a joke. Everyone knew this was a race engine. But as long as nobody said it out loud, the game could continue. The L88 also represents a time when engineers had more freedom to build something truly special. Today's engines are marvels of technology, with direct injection, variable valve timing, and sophisticated engine management systems. They make more power per cubic inch than anyone in 1967 could have imagined. But they lack the raw mechanical character of something like the L88. You can't adjust your own valves. You can't change the jets in the carburetor. You can't really modify them without a laptop and specialized software. The survival rate of L88 Corvettes is remarkably high for such high-performance cars. Of the 216 built, historians have documented over 180 still in existence. That's an amazing survival rate for cars that were built to race. Many were crashed, some were stolen and parted out, but the majority survived because owners quickly realized they had something special. Even in period, people knew these were future collectibles. The restoration and preservation of L88 Corvettes has become an art form unto itself. Finding correct date-coded parts is a treasure hunt that can take years. Some components, like the correct air cleaner assembly or the specific exhaust manifolds, can cost more than entire cars. The expertise required to properly rebuild an L88 engine is rare, with only a handful of shops in the country truly qualified to do the work. But the effort is worth it. A properly restored L88 Corvette is a rolling piece of history, a monument to American engineering at its most audacious. The stories of L88 racing successes could fill books. At Daytona, Sebring, Le Mans, and countless smaller tracks, L88 Corvettes proved that American engineering could compete on the world stage. They weren't always the fastest cars overall, but in their class, they were nearly unbeatable. The combination of power, reliability, and relatively low cost made them the weapon of choice for privateers who couldn't afford the exotic European machinery. As we look at the L88 legacy today, it's clear that this engine represented a pivotal moment in automotive history. It was the last gasp of the unrestricted muscle car era, built just before emissions regulations and insurance crackdowns ended the party. It was also a preview of the future, showing that sophisticated engineering could produce remarkable results. The aluminum heads, high compression ratios, and race-oriented design elements would all become common in later performance engines. The human element of the L88 story is equally compelling. The engineers who developed it working in secret to create something extraordinary. The dealers who had to explain to customers why their new Corvette had no radio or heater. The owners who had to search for race fuel just to drive their cars. The racers who discovered they had been handed a weapon that could dominate any track. Each person who touched an L88 became part of its legend. The philosophical question the L88 poses is still relevant today. How extreme should a street car be? The L88 pushed that boundary to its absolute limit. It was barely streetable, demanding constant attention and special fuel. But it offered performance that was otherwise unobtainable in a production car. It asked owners to sacrifice comfort for capability, convenience for conquest. Most said yes, and they were rewarded with one of the most legendary engines ever built. In conclusion, the Chevrolet L88 427 stands as a testament to what's possible when engineers are given freedom to build something without compromise. It proved that honesty isn't always the best policy when the truth would shut down your program. It demonstrated that American manufacturers could build world-class racing engines and sell them to the public, even if they had to lie about what they were selling. The L88 wasn't just an engine. It was an act of rebellion, a middle finger to convention, and a love letter to speed. The next time you hear about a modern supercar making 500 or 600 horsepower, remember that Chevrolet was doing that in 1967 with pushrod technology and a single carburetor. They just didn't want to admit it. The L88 remains one of the greatest engines ever built, not just for its power, but for what it represented, the absolute pinnacle of muscle car development, the ultimate expression of racing technology in street form, and the most successful lie ever told in Detroit. What's the most underrated engine you think deserves more recognition? Let me know in the comments below. If you enjoyed this deep dive into one of the most legendary engines ever built, make sure to subscribe for more stories of automotive engineering excellence. Until next time, keep those engines running, and remember, sometimes the best specifications are the ones the manufacturer doesn't want to admit.